Hello everyone and welcome back to the Recursion series. So this is the second video of this series, and the first video we discussed the basic concept and intuition behind recursion and a few tools like recurrence relation and recursion tree. So in this video we'll be using everything that we learned to solve a problem. So just in case if you have skipped that video, I would recommend going back and watching that video first and then coming to this video. So we'll be discussing a practice problem in this. So just a heads up that these practice problem videos are there to cement your knowledge of recursion and help you build up a thought process. But just watching these videos won't be sufficient. You would have to go back and actually try out some problems on your own, and that would be the best practice or the way to become very comfortable with recursion. Now, one more point, that if you're someone who likes to dive really deep into every topic that you study, then I've attached two resources or two books for you in the description. And one of those books is Cracking the Coding Interview, which is kind of like the holy grail. Everyone recommends it. So, if you're planning to dive deep, I would highly recommend buying that book and reading the topics from that book. So yeah, I usually don't recommend spending money because there are so many free resources you can get. No point in spending money, but these books are kind of the very few resources which are worth it. But if you're not planning to dive deep and you just want to understand the concept and you want to be able to solve questions, then this series should be more than enough. With that in mind, let's discuss our first problem today. And this is a very easy problem. Now, let's go through the problem once. What does it say? That given an integer n, return true if it is power of 2, otherwise return false. Very easy. You will be given a number n, and you just need to check whether this number is a power of 2. So, is there an integer x such that 2 raised to power x will give you this n? Very simple. So in the very first look, an iterative approach might come to your mind, that you'll take a current number and you'll initialize the current number as 1, and every time you'll start a while loop, and every time this current number is less than your target, you'll multiply 2 with it, and as soon as this current number is greater than equal to your target, you'll break this while loop. Now outside this while loop, you'll check whether it is equal to target. If it was equal to target, then definitely it's a power of 2. But if it's not equal to target, that is it is greater than the target, then definitely it's not a power of 2. So in first look, if this iterative approach came to your mind, that's very good, because I think the iterative approach is more natural and organic. uh, but again, so this can be solved recursively as well. You might find the recursive solution a little over the top initially, but yeah, once you understand the concept, both iterative and recursive approach will seem like kind of valid approaches to you. So let's try to understand how can this be solved recursively. So the first thing that we see to solve any recursive problem is that if this problem depends on a similar smaller subproblem. If this problem depends on a smaller subproblem, then probably I can solve that subproblem and use the answer from that subproblem to calculate the answer for my current problem. So let's see how this problem can be solved by solving the subproblems. And for that, let's take an example. Let's take n equal to 8. Now, how can we check that 8 is a power of 2? To check that 8 is a power of 2, we need two things. That 8 should itself be divisible by 2. That is 8 mod 2 should be 0. And the second thing we need to check, that n is equal to 4, which is 8 by 2, should also be a power of 2. Right? Makes sense, because if the current number is not divisible by 2, definitely it is not a power of 2, because there is a factor which is not 2. And if this number is divisible by 2, and when I divide this number by 2, the remaining number should itself also be a power of 2. Right? So this kind of seems that if I want to solve this problem for 8, I can solve this problem for 8 by 2, and I just need to check that my current number is also divisible by 2, and using these two, this And using the result of these two checks, I can actually tell whether my current number is a power of 2 or not. So now, since this is a recursive problem and we've seen that this problem can be solved by solving the sub problems and taking a step for the current problem, this should we should be definitely able to come up with a recurrence relation for this problem. So now let's say f of n is the function which returns true or false depending on whether n is a power of 2 or not. So f of n will depend on f of n by 2, so the result for n by 2, and whether current number itself is divisible by 2 or not. And using the answer for n by 2, we can actually calculate the answer for n. So this is a recurrence relation. So now let's try to draw a recursion tree for our solution. So for n, to find out the answer for n, what we do is we call the method for n by 2. For finding the answer for n by 2, we call the method for n by 4. And this process basically continues till my n is equal to 1 or it is 0. Right? So now let's try to see that what will be the height of this tree. So n by 2 till 1. So every time I am dividing my n by 2, so the total height of this tree is definitely going to be log 2n, right? So it will take me log n of steps to reduce n to 1 or 0 if I continuously keep dividing it by 2, right? Simple mathematics. So now we also said that recurrence tree are actually very handy in coming up with the time complexity for our solution. So first of all, discussing about the time complexity, so you might see that there are a lot of different methods to calculate the time complexity for a recursive solution. One of them is the substitution method, the other is a Master's theorem, but you rarely see that you'll be applying mathematics and solving the recurrence relation to come up with the solution. What you're required or what you're expected is that using some intuition, tips and tricks, and just visualizing how your code is going to run, you will be able to come up with a tight asymptotic complexity. Now, what I mean by tight asymptotic complexity, so what we generally discuss is the big O complexity, right? So what is big O complexity? So big O is not the exact time complexity, but it is a tight upper bound on the complexity. So when you say that something is big O runs in big O of log n, that means that the time complexity might be less than log n, but the time complexity for this solution will never go above log n, right? So but you can say, then I can say that big O of infinity probably, or big O of n raised to power a very big number, will always be the correct time complexity for every solution, because that will be the upper bound for every complexity. Nothing can go above that. But when we are telling the big O complexity, what we do is that we try to give a complexity as tight as possible. So let's understand it using a graph. So we might say that the actual complexity for a solution is 0.4n. Now if I draw the graph of n, O of n, and if I draw the graph of O of n square, you would see that O of n square is a upper bound for this complexity, right? O of n square is an upper bound for this complexity, and O of n again is a upper bound for this complexity. But when we are giving the big O notation, we'll say that O this solution runs in big O of n, because this complexity is a tighter upper bound on this on this time complexity. So whenever we are trying to give the big O time complexity, we'll try to come up with that will be an approximate time complexity, but that would be the tightest bound or asymptotically tightest complexity that we can come up with. Now, given that, here let's try to analyze the complexity of this. So whenever we are using the recursion tree to analyze the complexity of any solution, we need to keep in mind that essentially the time complexity will be will be close to the total number of nodes in the recursion tree, because every node, if you see, is representing a constant operation. So at n, there's a constant operation where we check that whether the current number is a is divisible by 2 or not, and then we call the method for n by 2. Similarly, here we will do a constant operation to check if it is divisible by 2, and we call for another method. So every node you see holds a constant operation, and then we are delegating the further problem to a shorter input or to a smaller sub problem. So if you see, as we have discussed that the total height of this tree is going to be log n, and how many, so at every height there's going to be one node. So if the total height is log n, then the total nodes will also be log n to the base 2, right? So what will be the time complexity for our solution? The time complexity will again, this time complexity for our solution will be log of n, where n is the input which we are trying to determine whether it's a power of 2 or not. Now that we have discussed about the recursion tree and we have found out the time complexity and we have seen the intuition of sub problems, how it works in how it is working for this particular case, let's try to actually code the solution of this problem. And while coding, I'll keep discussing the intuition that I'm following to map my recursion relation to the actual code. So as you can see, I'm here on Leetcode, and let's try to quickly code the solution and try to submit it, and let's see what is going to what is the result. So the very first thing that we discussed in our intuition is that we'll blindly assume that this method works for a smaller input. So we'll first get the answer for our smaller input, which is n divided by 2, and we'll assume that this answer is correct. Now what would be the final answer? So if we are assuming that we have got the correct answer for the smaller input, the final answer is nothing but we just check for our current input and use the answer for our smaller input to get the final answer. So we have checked that whether our current input is divisible by 2 or not, and we've used the answer from our smaller input to calculate the answer for our current problem. Now using that intuition we have done. So it was a two-step intuition, and the second step had to always be the base case. Now what is the base case? I kept dividing my number and the number reduced to 1, right? So when the number reduced to 1, it is obviously a power of 2, right? So because 2 raised to power 0 is equal to 1. So from here it makes sense to return true, because see, we have reached the case where we know that this is a power of 2, so definitely it makes sense. What is the other base case that we discussed? We kept dividing the number and the number reduced to 0. We know that 0 we can never achieve 0 by raising 2 to any integer power. So from here we will return 0. So now we have written the code. Let's try to submit it. Yes, and we have submitted the solution, and as expected, it is the correct solution. Now, one thing could be that we also discussed an iterative approach. So, what you guys can do is that you can try to code this recursive approach, and you can also try to code that iterative approach, and then check that which approach has a better runtime. And obviously, in my opinion, the iterative approach should have a better runtime. You see, the recursive approach is faster than just 41% of the solutions. So just give it a try. Try to run your iterative approach. So I guess that's it for this video. If you have any doubt, please do write in the comment section. Thank you, everyone. Stay safe and keep learning.